Okay, guys, thanks a lot for joining. And in today's meetup, we will be discussing deep learning for bin picking. It is the third meetup, and so I decided to name this meetup as Robotics and AI meetup because it becomes more clear as to what we are doing. So the agenda for today is such that I'll just begin with my introductory presentation for 5 minutes, and then after that, a particular volunteer is supposed to share his or her project experience for 20, 30 or 40 minutes, and that is followed by a Q&A session. So for today's project, I volunteered to explain deep learning for bin picking application, and I've made sure to make it beginner friendly, so anyone who has no experience either with deep learning or is totally new to robotics is also welcome, and hopefully this should also make sense to him or her. And after that, there is a feedback session for the presentation and also for the project process. What is the project process? This thing I'll also share in the subsequent slides. And after that, there's this section called project accountability share, which we have every week, where anyone who is partaking in a project and wants to share his or her progress for accountability can do so, but this is optional. And the last part would be just introductions and casual networking so that we can get to know each other well. So again, this slide I share in almost all of the presentations, all of the meetups, and this is just to show that we are a robotics and artificial intelligence community who are also trying to find new ways of learning, better ways of learning these advanced fields, and we are an active learning group in these particular fields. So the way we learn is that apart from the weekly meetups, we also conduct monthly research paper discussions. So at the end of the month, we would have one research paper discussion. It would typically be last Sunday of every month. And the other thing that we provide is project accountability. So that is separate from the meetup, such that if you are pursuing a project and you are looking for partners or collaborators, you can be active on the server and also connect with other people. There's a formal system that is developed in how it works channel in the welcome category, so you can refer that for more details. And apart from that, as I mentioned, in the meetup also we have a section of project accountability, so the person can share, and everything will be free and accessible to every member. Everything that we share in this podcast, in this meetup, I'm sorry. So what is the format of weekly meetup that we have? So this is something that I have made unique to this particular meetup. Before that, our meetup was not very well structured, so we were random in the way the projects were being shared, but I thought it makes sense to structure it a bit. So initially a person would be sharing his or her project, and the project would not be shared randomly. A problem definition would be given first, and then a brainstorming session would be there, so that everyone can participate and give his or her own ideas, such that we all can learn from each other. And after that, the person can actually elaboratively explain the project or case study solution that he or she has prepared. So for today's particular case, deep learning for bin picking is the project or case study. And after that, we'll also talk about concepts covered in the project or case study presentation, because you can also learn concepts individually, but I think that a better way to learn is that if we learn these concepts as they are being used in applications, projects, or industry, so that you get to understand how these concepts are being used. It's a similar thing to how we learn words or new vocabulary, such that the best way to learn is to use these words in context and not to just memorize words as individual blocks. So that's the idea behind it. Of course, we can also discuss what your views are about this. And the last is applications. what are the applications in industries, because project is being shared, but a similar idea could also be applied to a wide variety of fields, and that is something also that would be beneficial to a lot of us. And the last thing I want to share is that we are a volunteer driven community, and so we need a project presenter every single week for us to carry on with this and also learn from each other. And also, the same applies for research paper presentation, which is once a month. So, feel free to also volunteer, and it doesn't have to be perfect, right? If you have any idea, any project that you want to share, we can just have a casual discussion. You don't even need to make a specific presentation, but I have prepared a template for the presentation for those of you who might need it. So I really encourage everyone to participate, because the goal is just to learn from each other, and the more people that share their knowledge, the better it would be. So let's start with today's project. So the today's project or case study is that of deep learning for bin picking. So how I go about is I'd first explain what the bin picking problem is, how we use deep learning for bin picking, and then the concepts covered. And then the concepts that are used for used in this deep learning based pick and place system. So the concepts come only in context of the project as a whole and not as individual blocks. So the concepts that will be covered are basic deep learning. I've tried to keep it very basic and not going into a lot of details, because that would take many hours, and we have like limited amount of time today. So, and after that we have application. So yeah, that is the thing that will be shared, and it is beginner friendly again, so anyone should be able to understand it regardless of experience. So what is the bin picking problem? So you can imagine that there's this random pile of objects in a bin, and a robot has to pick it. So it's really how we define a bin picking problem. And for that, the given thing is random pile of objects and a 6 degree of freedom robot manipulator arm with two jaw gripper. Ideally, lots of different types of grippers or robot manipulator arms or systems could be used, but for this particular case I'm taking a 6 degree of freedom robot arm with a two jaw gripper, as you can see in the image, and the task will be to pick objects one by one. So as you can see, these are like totally randomly oriented, so that brings to the challenge of the pin picking problem. What are the requirements of the for the robot? So the robot doesn't really care about how the object is. For it, the most important thing is having a robust grasp pose, having a particular jaw opening defined based on the object that is being picked, and the grasp forces, and that would also be dependent on the object. So by robust grasp pose, what is meant is that the end effector or the gripper of the robot should have its position and orientation at which point it should go so as to pick an object, right? And the jaw opening is simply the opening of the jaw so as to pick an object, and the grasp forces are again the forces that the jaws should be applying on the object so as not to damage it, or even not to apply less force such that it slips. So as you can see, for our particular problem, there are a variety of objects, and this adds to the complexity of the problem, because the grasp poses would be variable, would be different from all of the objects. The jaw opening would be different, the grasping forces would be different, and this could be a research problem in itself. So let's try to simplify this problem and try to understand a very simple case study, because we are kind of going about it from beginning right now. So the simplified problem is a random pile of single type of objects are available, right? So for this case, you can see connecting rods from an automotive engine. They are in a bin piled randomly again, and we also have a given 3D object, and the task is again to pick the objects one by one. Requirements remain the same, that we need robust grasp poses, jaw openings, and grasping forces. So So at this point, I'd like to just pause and have a quick brainstorming or discussion session where each one of us can contribute his or her ideas right now. Like, what do you think could be an approach to solve this particular task? So, anyone would like to give any random idea, any vague idea, anything is welcome. It's just a casual brainstorming session. So, given a bin of random single type of objects, how does one begin with picking the objects one by one? We do not have any other data except that we have a CAD model of one particular connecting rod, uh, and we need the grasp poses. So would anyone like to contribute or give any random idea? If not, we can also like discuss it at the end when things are more clear.
Hmm. Not to be specific, but like I wanted to understand the problem statement, so I'm asking this.
Okay.
Uh, so we will be having a box where there will be different sized objects, and we have a robotic arm with us, right?
Yeah. So this, for this simplified case, the object is the same. Same type of object is there inside the bin.
Understood. And there is a camera associated to the robotic arm.
So this camera and we don't have any of the details right now. That would come as a later part of one of the solutions probably. But in the beginning, I'm trying to keep it as open and creative as possible. So you could think of any of the ideas. Yes, you know, capturing images from the camera could be one direction. So what do you think? How can we calculate grass poses from that? Could you give some
Mm,
ideas? Like, it has to be like totally random. What do you think right now?
One suggestion, one idea could be like, since we know, since the object is of single type, we
Yeah.
can basically estimate what sort of sizes are available with us. I mean, uh, not very sure about how we can approach the grasping part, but
Hmm.
mm,
So
no,
do
it's
you
too early
mean,
for me to, yeah.
okay? Do you mean using the 3D model for the dimensions in some way, or are you talking about the images?
So I was thinking to basically fuse the endpoints, basically, like if we could find some way where we can identify the whatever object is there, we can identify that this is one point and this is another point in the image. Like at the end, the image is always a 2D representation, and we have with us the CAD model, which is a 3D representation. So
So
not sure. Yeah.
okay, but yeah, I mean, it's somehow going towards the right direction, right? So you want to identify the grasping points from the images. You are not sure how you would be using the 3D model in some way, right?
Yes. Yes.
Yeah,
Yes.
yeah, yeah. So yeah, that could be one direction. There could actually be a lot of different ways of solving this problem. That's why I've like kept an open problem here, and I would be willing to think of new solutions and ideas as well. So anyone else also wants to share something, some any vague idea, anything that comes to your mind?
So I'm thinking that if we have CAD model uh, the object uh, already with us, so like we can first train the robot to grasp that object from a particular point. So there will be, so like robot is already trained uh, with uh, like using machine learning, that how at from which point should pick that object so that the object doesn't fall or hang out, or there would be like uh, equal balances of forces. And then when the robot needs to do the testing or the actual real case scenario, uh, it will there will be a camera at the end of at the end effector which will through which we can determine the orientation of that object which is lying on the box. And since the robot is already trained to catch the object from a particular point, it will determine the orientation, and the end effector uh, end effector has that motor, right, through which this end effector can rotate. So it will rotate to get the same orientation which we have trained it for, then pick the object from that same location.
Okay, but are you training in the in simulation? You said you are using the 3D model.
Yeah, we can do that, or we can do like actual training also, like with real objects.
And what are you providing? Like, what are the inputs to your training model? Hello.
Hello.
Yeah. So the inputs to your are you feeding you're feeding 3D model, and so I didn't fully get, like, what are you trying to feed to the model basically.
So like we'll feed like the design and the orientation of the object. So like while training, will like suppose like the robotic arm, there is only one object which is placed on a surface and the robot has to pick it up. So
Okay,
we'll
so
train it that it will pick it up at a particular orientation. And when there will be a real case scenario where there will be a lot of objects which are lying at different orientations on a box or any surface, robot will orient itself to
okay.
pick.
So you're kind of just determining the grasp pose of one particular single connecting rod from simulation, and
Yeah,
probably you don't need machine learning for that, right? I mean, uh, you could just be selecting one particular grasp pose for suitable to the shape of the 3D model, right? And then you are trying to apply it on a heap. I don't know how that thing could directly be applied on the heap. I think because, I mean, how do you identify one particular connecting rod from the heap? That would be the challenge, right?
that would be then the vision problem. I
Yeah, yeah, yeah.
For that, I have one suggestion. Uh, can you hear?
Yeah,
Am I audible?
we can hear you,
Yeah,
yes.
yeah. So, thing is, what I was thinking, as Apurva said, that taking 3D model and images. So, assuming that as a 3D model, what we'll get is like only one image, right? It's basically when you get a 3D model, you get one file which has a ideal picture of how this piston leg will look like.
Exactly,
Okay.
yes.
Yes. And from image perspective, what we can see is a lot of piston legs are kept there. All these things are kept on top of each other. So when we look at from top of it, what we have the significant features. So like from this, at least three things I can see very clearly is that there will be one big circle, one small circle, and and two straight lines which are connecting these two circles. Okay, so what if we can do like this, that from top, when we take a picture of it, all we have to do is first of all identify for at least any one object which is having all these three significant features very clearly visible. Because if something is on top of anything, you have intersecting lines and it is not complete.
Yeah,
But because everything is kept on top of one other, there has to be at least one object which will be clearly visible.
yeah, the one that is to be picked.
Yeah, one that is to be picked. Now comes that this 3D model. Now from this image, if we have this three features distinctively available, we can calculate the way it is kept, right? Basically we just have to get a bounding box around it. if we put it in that way.
So a 3D
Okay.
bounding box, you mean?
No, you don't. No, again, it doesn't have to. I'm still not in the 3D model. Still,
Okay,
we're
okay.
on computer vision level.
Okay, yeah.
Okay, so from this we can actually get one bounding box which says that this is the approx place where the object is sitting.
Yeah,
Right now, from this object, we can from a 2D space we can identify at what angle it is. Right, because it is
yeah,
not compulsory that every time it will be on a similar position.
exactly. Yeah.
Right now, at this point, when we know that, let's say that one ring, the one which is having that orange ring on top of it, I think clip O-ring is there.
Yeah.
Yeah. So for that one, assuming that it is kept, let's say, some at 45 degree. Okay. If assuming that I am able to calculate that much, then we can superimpose the 3D model on top of it to get the idea that how approx that object is right now.
Okay. Yeah.
And I hope from that point, because I don't have much idea about robotic grasp points, but I think from that perspective, we may be able to get a general idea that this is the place where we can have a first pick.
Yeah. So basically, I mean, what you're doing is you're trying to identify just the connecting rods individually and find correspondences with the 3D model, right? And based on that, you can get the orientation as well. So this
Yes,
is
exactly,
kind of
exactly.
your idea. So,
Yes.
but I think the thing that is so for the machine learning model, what you are feeding is for one particular image, you just want to feed one object to be identified, right? The one particular object in the screen. So that is, I think, difficult to determine because either it has to be because which object is on the top, it also probably needs the depth data, right? Because the
I
topmost
think that
object
is where
has to
our
be.
this deep learning model will come into picture to identify which is the object which is on top,
Yeah.
and can we localize it.
Okay. Yeah,
I
that's.
mean, that is how I'm thinking.
I have a question over here.
Yeah.
So when we say that we want to calculate the grasp point with respect to the robotic arm, so will we need to consider the distance at which the robotic arm is kept from that box, like the like how basically a robotic arm moves? Like I don't know much about it. Can you give a glimpse on that? Like how what command does it take and how it
Okay.
basically.
Yeah, same
So,
question.
I mean, are you aware of the inverse and forward kinematics models, maybe?
Yes, yes, yes.
Okay. Yeah. So once you determine the grasp poses from a deep learning system or any other way that you are doing, then you just uh, feed it to the end effector position, and then with inverse kinematics we get the joint positions, and then all the joints go to that position, and it goes to the grasping position, and then maybe you give command of closing the jaw and picking up and going to a home position. Was that
Understood. But
was that your question or?
yeah, a bit on that, but I have this one doubt. So every time, like the pile, the heap will start reducing. Like when we pick, we drop, we pick, we drop. So
Yeah,
then it will go more deeper, and the joints have to turn more deeper to pick the objects. So the
yeah,
distance of the objects from the camera will start varying, right? Like it will
exactly,
increase. So how do we need a depth camera over here or depth knowledge about here? So how we
exactly.
gonna
Yeah,
determine that?
yeah, exactly. So yeah,
So
that's a very good
maybe
point.
I would want to add here,
Yeah,
yes, your question is exactly valid, like how you can validate or how you can capture the position with the moment the objects are picking again and again. So as it was already discussed, the best one of the best solution from the industry front is like you will have a 3D depth camera to identify the 3D. Actually, you will use machine learning algorithm, computer vision algorithm to identify the uh, position or object position with respect to 3D world, not just in the 2D world, and also which can also give you the orientation. So this how it works. Like you will have a fixed location of camera in your cell, and you would have already given feeded the camera location in the robotic system, and there will be a transformation from the end effector to the camera, and from the camera to the object identified will be done. The transformation matrices will be calculated, and the complete forward kinematics will be calculated, and based upon, and in the 3D world, the object location would be identified from the camera and will be given to the robotic system, and from the object location to the end effector position, this transformation would be calculated on the fly. Then the robot will be able to pick up the object as you go on picking up the objects, even though if you go down.
Yeah, exactly. I think Vamsi answered your question, right?
Yes, yes.
Yeah. So yeah, using the depth camera is also in the pipeline that I will be sharing in the solution. But also, like at this stage, we are open to any crazy ideas or anything, uh, any other method that we probably could not have thought of getting the depth, measuring whatever you think. So anything else anyone wants to add, any idea that you think of right now? You already have like shared really good ideas, and it I think all of so we have like two or three different kinds of ideas. One is using 3D model correspondences with image, and the other is using just image data, and using the depth for the understanding how deep the object is, and a few other things. So any other ideas are also welcome here if you want to share.
From my point of view, I don't think so. There would be any other ideas. For example, like you need a depth for
Yeah.
activity cost, but either that can be possible either through 3D depth cameras, or maybe we can use some infrared radiation or to identify the depth of the object or something like that. Or
Sorry.
maybe we can even use triangulation method to identify the object position in
Okay.
the 3D space.
Yeah, yeah, yeah. Yeah, I mean, so yeah, triangulation is that's actually another way we can uh, get the depth as well without using the depth sensor. So that could be one idea. Other computer vision techniques can also be used.
Uh, Guys, when you say triangulation, can you please tell? I don't know what that means. Sorry.
Okay, the triangulation method means you can identify the object position in the 3D world by using two image captures with different positions. So you will be estimating the 3D object position in the 3D world with two images using triangulation method. Like you will project 2D images into 3D space, and
Okay,
then
so it's like
yeah,
projecting 2D into 3D space, right?
yeah, but not with one single image. You can use multiple images
Yeah.
or more than two images if
Ah,
required.
okay, okay,
So, but
okay.
not at the same location also. Even if the images you have multiple images, it won't give a triangulation, but it should be at different locations. So in such cases, that is what actually our mobile phones does because of the dual camera in the behind. What it does was the cameras are at different locations. When it captures, it is able to identify the depth of the image so that it can able to differentiate the foreground and background. This is basically done based upon triangulation method.
Yeah. So if you mount a camera on the wrist of the robot, then it can be moved to two particular locations. For example, so you have two images from two different viewpoints, and then triangulation can be applied to get the depth. Yeah, that's another
Yes.
good one. Yeah.
And the entire, just one question, the entire requirement of having this depth information is to identify because as someone said that every time we pick a object from the bin, the distance will keep on changing, and for that we need this depth, right?
Yeah, and it should be
Uh,
continuous actually. So the depth should be continuous after each iteration of picking and placing. The depth has to be measured because it would be changing.
yes. And also not just for the identifying the depth of the objects, the depth information would give us the orientation of the object as well. Why? Because in the 2D perspective, it is very difficult to identify the 3D object in the 3D space. So if we have some depth information about the object itself, the robot can be moved towards that orientation, and as well as the location of the object, how it is oriented. For example, if at all the object is lying entirely like 90 degrees from the, for example, that red wing object is lying 90 degrees, it is very difficult to identify, or maybe like more than 45 degrees, it is very difficult to identify the orientation with just 2D images. In my perspective, not just for the identifying the depth of the object location, but also identifying the orientation of an object in 3D space.
Yeah, I mean
So
that could be like one of the solutions, right, Vamsi? So for estimating the pose, like using the depth image could be one of the solutions. Another could be using a PNP algorithm, right? So simply put, like
Yeah,
having correspondences with the 3D model
correspondence.
of the image. Like there are like uh, uh,
Multiple vision
multiple
algorithms are there.
ways.
Like
Yeah,
I mean to say, like for example, if an application, if for example in such applications where bin picking is not there, but everything is assorted on the same level, but yet some requirements you can use 3D depth images to identify the orientation, and not just the position and the location, but also how the object is oriented in the 3D space can be estimated easily with respect to 3D images. It is possible with without 3D knowledge as well, using, as you said, like stitching, image stitching methods as well, like PNP algorithms, as you said. But yeah, with 3D depth, we not just that we only assess the depth of the object in the bin, but also we can identify the orientation, position, as well as like how
yeah.
it is oriented in the 3D world.
Okay, yeah,
and
that's true.
what if we take out the entire need of having the depth idea? What if we can remove this entire need that we need the depth information?
What do you mean by that? Like, what would
So
be an
basically,
alternative?
if I'm looking at this image right, so the depth we need is so that our robotic arm can actually go down and come back, right? The
Exactly.
Z axis.
Yeah. Yes, yes,
So
exactly.
yeah, and because it is when we say we have to pick the bin, it will be very much controlled environment, right? So, and we have this 3D model information. When we say 3D, by default, we know that what will be the height, width, and length. So, no, it won't be just length and width, but we'll also have the height information or
Yes.
other way
Uh,
around,
yeah, but
right?
the thing is that these are arranged in a random fashion, so you can see like
No,
multi.
no problem, no problem. They are kept in a random fashion. But is it possible? I'm just asking it. I'm not sure. It just I have this idea that is it possible that we can actually train a model that can give us an idea about how many number of objects can be placed in a given cube, empty cube? Because what I can see is it's a empty cube, blue box, basically that container. Okay. And suppose we have this information, instead of one 3D object model, we'll need two 3D object model. One, the container, and the second is the object. These two 3D models. And can we train a model that will say in this way that how many number of this object 3D models can be placed inside one 3D object?
Okay, I get what you're trying to you're trying to change the problem, right? So the
So
problem is that it's a random pile of single objects. So if you arrange it like in a systematic way, then it would be
no,
like
no, no, no systematic way. Because
okay,
what will happen? Suppose if you have a one by one square,
yeah,
okay, and suppose your uh, object is of size, let's say 0.35. Okay, so by default, what I can see is maximum if everything is exactly perfect. That what I can see is I can keep only two things, three subjects on top of each other.
but
Because what will see
they are also
you
at
keep
like an angle, right?
yes,
So
yes, they will be the way right now. This all these rings are kept right now. All these hardware pieces are kept right. They are not kept in a very specific, very systematic manner, right? They are just dropped.
yeah, exactly.
Right, so can we actually train a model which can give us an idea that if this is the if this is the size of my blue box and this is the size of my object, how many a general approximation, how many such objects can be filled inside this blue box?
But I don't
Can
understand why do we want that? Why do we want
No,
that?
because if that is the case, then you basically have the idea how many, because every time you pick a object, you will have a rough idea how much of a depth has increased because from
Okay.
your 3D model, you have the width of the object, right? So every time we'll be just subtracting that much part. So you will be adding that much height, that this much deep more you have to go.
Mm.
Um, so the thing is that you're trying to have an approximate height based on approximating the number of objects that can be fit. But I think that would be like very approximate, and since the objects are placed totally randomly, so and a lot of the objects are inclined in random positions, and
Yes, they
yeah.
are random, but again, uh, they will be in a pattern, right? Because when you put objects, if you put it, if you shake that box, what will happen is the one which is having the object which can take the most, I'll say, keeping one plane straight, that will be the one which is going down, and eventually that pile will come. So you will eventually you should get a rough Gaussian distribution on top of it.
And how do you get depth from that?
So now suppose within the box when you put all your objects, so we know that in general it has to have a very rough Gaussian distribution. Now from your, so suppose at your mean you have your heap is at the highest possible height that is there. Okay, and now when you pick one object, so basically when you take out one object you have to reduce the width, the amount of
Yeah, yeah,
width
yeah.
that is there.
Okay, okay, okay.
So every time we pick a object, we know that from the mean this much we are going down. And
Yes,
this,
it's a very interesting proposal. I would like to share something more simple, if I can
okay,
say it like that. Let's assume that we have a camera attached to the robot. At first, we make a picture and we found a couple of ellipses, not a circles, ellipse. And dedicated system take decision to change the angle of the robot in order to catch the full circuit. That means that in this position, the robot is exactly on 90 degrees in front of one of the details. It doesn't matter which one. And we know what is the size diameter of the circle from a distance, let's say half of a meter. Know what is the diameter of the circle in the taken picture, and with the comparison, we can calculate what is the distance between the camera and the circle. That gives us the distance from the robot to the part. I don't know if I explain it good.
Okay, essentially you are getting the ellipses just from the identifying circles in the image, right? And then sorry.
Yes, at first we identify the ellipse. After
Yeah.
then, start moving the robot in position in order to see the circle, full circle, not the ellipse but the circle.
So the
And
robot goes
uh,
closer, and the camera is it mounted on the wrist or on a separate location?
so, sorry, can you repeat? I missed the beginning.
Is the camera mounted on the wrist because you go closer and try to get a full circle? You go closer to one
Ye-
object, right? And how do you go
Uh,
closer to, or how do you decide which object to go close to?
yes, the camera is mounted on the robot.
Yeah, yeah.
Yeah. And at first, okay, the robot is on some distance. Let's assume it is something like half of meter.
Yeah.
And since the camera catch a full circle, we can measure what is the diameter of the circle.
Yeah.
And we have as a condition that, for example, the diameter of the circle from a certain known distance, we can compare what we measure and what we have like initial information, and in this manner to calculate what is the exactly distance between the detail and the camera.
Okay, okay, okay. Yeah. Yeah, that sounds reasonable. Not sure how accurate that will be, but yeah, I get
It
what you're
depends.
saying.
Yes, it depends of the camera, in fact. But this is a full 2D approach, not using complex 3D models. Because this example, by my opinion, does not need to be used 3D models. We need only 2D and distance.
Okay, okay. Yeah, I
That
get
sounds
that.
actually very interesting. Like maybe I can add to this. Like as he said, like we can capture image from at some top, like maybe out some meters away from the bin, and then find out which ellipse is more likely to be a circle, and go
Exactly.
towards that and go to that
Exactly.
ellipse,
Yeah.
and maybe find take some more pictures to find out the position of the ellipse so that I can be circled so that we can have the exact position of the object. So in that way we can use only one camera object but with two images from one single camera, and we can have a kind of it can be a precise one. It is quite interesting that without using any 3D representation
Yeah,
we
yeah,
can.
yeah. Yeah. Yeah, yeah, this is a pretty different approach, but yeah, it makes sense. It makes sense. It's another good solution. So yeah, any other ideas anyone wants to share?
And then
So
if I
this
may
was
interrupt you, I think
sorry.
it's better to continue with your ideas, and maybe at the end, with your presentation at the end, we can ask for all the
Yeah,
questions.
sure, sure, sure. Okay. Yeah, I think we already discussed quite a few
Yeah, we
ideas
spent
there.
a lot of
Yeah.
time for this in this slide. Yeah.
Yeah. Okay. All right. So I'm choosing a very simple system, and I mean based on the interest level we can also discuss in more detail. So the hardware setup is such that we have a robot manipulator arm with a 2-jaw gripper and the bin with objects, and I'm just using a RGBD camera, stereo vision, not stereo, so RGBD camera with the depth sensor as well, so we get the depth. And for the software setup we have a robot framework, which could be ROS or any other framework that other frameworks that are being used. And so I'm using an image segmentation model. I'll explain how that fits into the pipeline, and a data set which only consists of images of heap and grasp label. So actually the model, depending on the pipeline, the model would change. If it's a segmentation approach that we are following, we could use a segmentation model like mask RCNN and other models. And if it is just object detection, then we'll choose such algorithm. So mask RCNN actually does both object detection and segmentation. And for the data set to feed, we have images of heap and grasp labels. So this is like super simplified pipeline that I'm trying to explain, because I think a lot of people already have experience with the deep learning and stuff, but for those people who are new, I also want to make sure they also understand most of the portion. So the camera that is mounted, it's not mounted on the robot. Actually, it's mounted on top of a frame, on top of the heap, actually attached to a frame, so it's fixed. In this particular pipeline, of course, there are like multiple solutions that are possible. So as the image is captured, it's fed to a deep learning model, and a grasp pose is predicted for this particular image. So this is like super simplified how the deep learning system is. I'll like briefly explain as well, and we can discuss in more depth as well in subsequent slides. And what happens is that once we find the grasp pose, it is fed to the pick and place pipeline, such that using inverse kinematics, it provides the joint position such that it goes to the grasping position, picks it, goes to a home position, and drops it in a position outside, maybe, for example. So this is a very simplified approach, and for this, gladly most of you are already aware of the machine learning concept, but still I'll just cover briefly the basics. So difference between the machine learning approach and traditional programming approach is that in traditional programming, we feed data as input and we get answers as output, but in machine learning we feed data and answers as input and we get the rules as the output. So what is let's take a simple example, very simple example. So for data, let's say we have this particular list of numbers 1 2 3, and the rules are such that y is equal to x minus 1, just a normal line equation, and the answers, if you put x into this, you get 0 1 2. So in traditional programming, we feed x into it and we know the rules and we get the answers. But in machine learning, we feed the data and the answers and it predicts this equation. It finds this equation automatically. So that's the advantage of machine learning. And a quick difference between machine learning and deep learning is that the features, so there's also a neural network, which is an approach of machine learning, and for that, in a machine learning approach, we find features separately, we extract features separately, and then we do the classification. So for example, for this input image, whether it's a car or not, we extract some features and then we feed it to a network. Just think of it as a black box. Whether it's a car or not is being predicted for a new input. And for the deep learning system, the feature extraction and classification are being done internally, so it calculates features automatically. So this is just very quick. What is important is how this is being used in the system. As I'll just take that simple example and see how that fits to deep learning. So data and answers are fed to the deep learning system, and for a new value of x. Now why the deep learning system is important is that it should predict an output based on the rules that it learned from the data and answers during training, and it should predict an output for a new case, for a general case. So another quick concept that I want to share is that of train test split. So we also want to know how accurately it predicts a new output, right? For a new input, how accurate the prediction is. So for that, we first split the data and answers into train and test. And what we do is that we compare, we predict on the test set first and see the prediction with the actual answers, right? So the answers, for example, would be 7, 8, 9, and the prediction maybe it's 7.5, 8.2, or something like that. And then we compare it basically with the test answers, and from that we get a prediction percentage number, and we get a percentage of how accurate the prediction is, and then we know that okay, this has predicted it, but it's only 70% accurate or 80% accurate. Don't worry if this is not clear to you, if you're totally beginner. The point is to see how this is being used in the system. So we are feeding data and answers, right, for the deep learning model, and then the deep learning model is being trained so that it learns a pattern, right, or weights, as we say in a neural network, but I'm just keeping it super vague right now. So we train the model by data and answer. So what is it that we are feeding? This is important to know, is that for this particular pipeline, and this is a very simplified one, we feed sets of images captured of random heaps. So we generate random heaps and capture lots of images, and then we label a particular grasp position manually, right? And for each of these images we do it, and then we feed it, then we train the deep learning model. So the deep learning model now understands the rules behind it, the features and everything. And now for a new image that is captured in real time in the pipeline, it predicts the grasp pose. So that's how the concept of deep learning is being applied in the pipeline. And quick, I think all of you all I think know about inverse and forward kinematics, but just quickly that for this particular picking case, we know the end effector, the grasp position is being fed to it, and then the joint positions are found out. And this particular case is inverse kinematics. And the case where we already know the joint positions and we want to find out where it will go, that is the case of forward kinematics. Right, I'll just finish through the slides, and then we can discuss, like if you have some doubts or something is not clear. So this is how the whole pipeline fits now, is that as I mentioned, so it just predicts a grasp pose for a new image, because now the model is trained, right, from the data set that we fed into it, and then it is fed to a pick and place system, and then this is where the kinematics part would be in function, because end effector is fed and the joint positions are being calculated. So this is a simplified problem, and finally we can also discuss it. I realized that I could have like made it a bit more elaborate, but I didn't know what to expect and what everyone's level of understanding was. But yeah, now we can also discuss ideas, doubts, or anything quickly about the problem. So was everything clear about the deep learning system, or are you guys already aware about deep learning? What are your backgrounds? Maybe we can also talk about that. Hello.
Yes, hi.
Yeah.
So, no, at least, well, I understood your things because I have read through RCNN and those papers. For my experience as for deep learning, I have worked extensively in fashion industry as machine learning engineer.
Oh.
So, I worked there for almost 2 years. So I have used CNN papers. So
Okay.
I so actually, when you gave that idea initially, when you said that yes, simply by deep learning we can do it, I actually realized that yes, instead of going and banging head here and there, I can simply use one of the models to fit to my case. That was the thing. But yes, for us, very simple, like off the shelf results. This is, I think, is one of the very best answers we can have.
Yeah, I mean, I picked the most simple. I mean, it's probably unrealistically simple, the case that I've taken, but one particular solution would also be to just find segmentation masks, which is
Yes,
what I was
exactly.
going to cover like previously, but I just kept it like even simpler. And after, from the segmentation contours, maybe you can find a center point or a grasp pose from that somehow. Uh,
I think for if we can extend the RCNN model to further train the mask RCNN using the 3D mesh that you have provided as an input.
3D model, you mean?
Yes, yes, 3D model that you have provided. That should give us the all the necessary information that are there, that are needed basically to make your robot move according to the need.
Yeah, 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 for sure. Yeah, and what about others? Are your backgrounds was are you guys already familiar with deep learning and robotics and stuff like that? Or I know, I mean, I know Tanuj already knows this stuff. Vamsi is like my batchmate, so he also already knows this. And Dimitrov, maybe you can tell a bit about yourself as well.
Oh, my name is Dmitry Dimitrov. I'm from Bulgaria. My interest is process automation of discrete and continuous processes. Currently, I'm responsible for engineering department of a multinational company, and that's in general. I've been working maintenance team, in automation team. I've been team leader of automation engineers. Almost 20 years of experience.
Okay, that's great. And have you also been associated with the deep learning CV models and stuff like that?
No, I've been working on one project maybe 3 or 5 years ago with neuronic networks, but not deep learning. I do not have experience with this approach.
Okay, okay. So the concepts like vaguely were clear to you, right? How the whole system is working.
Yes, it is interesting, but for sure I must to spend some time to get knowledge in more deeper like that.
Yeah, yeah. And what kind of projects have you been doing? Like you have plenty of experience, right?
Mm-hmm. Yeah.
So the kind of projects that you have been like involved over your career.
Sorry, can you repeat?
So I was just asking, what kind of projects were you involved in? Have you been involved in?
Yes, I understand the question. Currently, I'm working exactly on a very similar project. What is the topic of this meeting? Beam picking.
Yeah.
Using using by industrial cameras. For example, Cognex. I believe that you know them. And Cognex with combination with Fanuc robots.
Okay. Yeah. So and you are mostly involved in software development, right? If I understood correctly.
Uh, yes, in fact, we are a team of automation engineers, and I lead them. and yes, we are more in software side.
Okay. So yeah, I mean, you could also do you also have you been working with PLC as well? Because I think Fanuc
Yes, in
robots.
fact,
Yeah.
yes. In fact, I start with this many years ago. We working currently our team as a standard in the company. We're working mainly with Siemens.
Okay.
Uh,
So this is also
mm,
something that you can be sharing in one of our meetings. I mean, how the PLC systems are. This would also be relevant to the meetups as well. So if you are comfortable sharing, you are free and open to share any ideas, any of your experience that you have.
okay, sure, yes.
And I
Mr. Dimitro, may I know, like, I heard that you're using Fanuc robots to solve this bin picking. Like, so in your project, are you also using 3D depth cameras or 2D cameras, which offers from Fanuc, or you're using some third-party cameras?
The idea is to use a real 3D camera, not 3D profiler.
Okay.
Because you know that Cognex had 3D profilers for
Yeah.
moving objects inline,
Yeah.
and since already more than 1 year, they
Okay.
have a real 3D cameras, and we just start working on this project. And since we
Okay.
have something interesting, Rich, I will share.
Yeah. Sure.
yeah, actually, I was just going to point Vamsi to you because Vamsi was working in Fanuc before, so it would be very relevant to you, to Dimitro, what you're doing there.
No, maybe in some other meeting, or I don't know
Yeah.
when.
Sure.
Hello?
Maybe Mr. Dimitro, you can post your, like, we can have a chat room, special chat rooms. We can also meet individually. We can even speak together. Yeah.
Mm-hmm.
Yeah,
Okay.
definitely. So yeah, I mean, after we finish it, so I mean, I don't know how many chat rooms you would need, but there's like this one-on-one chat room where two people can interact, or like 10 people. We have like so-called coffee room and other room. So just let me know. I'll create an additional room or anything. You can individually interact. Okay,
Okay,
great.
maybe later I will get in touch and
Yeah.
we'll
Sure.
organize.
Sure.
Okay. Yeah. So meanwhile, I can continue with the presentation. So that's like more or less how the deep learning system is working. I think the idea of it was clear, right? Calculating the grasp poses, because to explain deep learning, that's like a whole subject, and that would probably it would take some more sessions to explain that. So yeah, some alternative pipelines that I have mentioned, just a few of the many that are possible, is to train model on synthetic data set. I think some of the people also here mentioned, right? And then inferencing on real time images. So the challenge for this to be a challenge for this would be to have like realistic images. So what we are doing is we are generating simulated images from a simulation environment, and the 3D models would be falling randomly to form a heap, and then we could do rendering, and also domain randomization is a term that is used. Domain randomization means that random properties of texture are applied to make it look more realistic, to make it also work on real time images on inference. So that is one approach. And then other, I've already mentioned image segmentation model. So maybe circles could be segmented, or maybe the middle portion is probably a good grasp region, I don't know. That portion could be segmented, and a particular grasp pose can be calculated from these segmented portions. and that could be one pipeline. Another could be 6D pose estimation of the object. Since we have a 3D model available, like we can match the model to one of the objects that is being detected, and superimpose the model on it, and have some correspondences, and that's why we superimpose it and get 6D pose of the objects. This could be one way. Another could be, we mount a camera on the robot and we move it around and try to just, using a visual slam approach, try to get a map of the environment, and then also do a modeling of the whole bin to get a whole 3D profile. And then today we also have the depths and the whole profile. Not sure how good that would be, but just another idea that I would like to mention. So these are the alternative pipelines, and I think this was it from my side. And I'd just like to mention that for the next meetup we would like to follow the same system. I mean, I don't know how effective it was, and I would love to have your feedback. But what my goal was to discuss a project, and with a problem definition, do some discussion, which went, I think, really good, and present my own solution, and then the concepts covered, which were deep learning and kinematics in this case, so that the concepts are relevant, and a few applications. So for bin picking, I think the applications are clear, right? It could be anywhere where we have these random heaps, like even in automobile or even in mobile manufacturing, anywhere where we have random heaps. And this is another template of how the index would look like: problem definition, project explained, concepts covered, and how we would define the problem, and the main concept part. So this is like a format that we want to keep so that it's more standard. And that's it. And I'd like to have two feedbacks from you guys. First of all, how did you find it? Was it really helpful? How can we make it better? Because we are trying to, be effective with learning as well. How can we make the most use of this particular time that we have? And the second is, what do you think about this process of sharing? So project with brainstorming, solution, and concept. So yeah. Now I'd like to know individually what you guys think. Vamsi, would you like to give some feedback?
For me, it's everything's fine. So maybe we can continue to do in the same way.
Okay. And regarding the process, do you think like we should have this brainstorming discussion in between, after the problem, or at the end? Like, what do you think?
What you did was fine, but maybe a little bit lesser time for brainstorming
Okay.
during the presentation. But maybe we can allot lot more time after completing the presentation, so that people may have much more ideas and thoughts while going through the presentation. So maybe it's okay to have a brainstorming session in between, but not for more time.
Okay. Okay. Yeah. Thanks, Vamsi. Apur.
I think there is a spam account entered to the server called Marshmallow. I
Okay.
think you should remove it.
Where
Yeah.
where
I
is
just
it?
saw.
Okay.
I
General
just
health.
clicked on you. Its status.
Okay.
It's
Okay. I'll remove that later.
yeah. I just saw, so I thought to inform the concept. So,
Yeah.
okay.
Thanks. So I've cancelled the member role of this profile.
Yeah.
So yeah.
Gone.
Yeah. So, Apurv, what do you think? Like, was this thing helpful? How can we be more efficient in learning?
Yeah, it is helpful and this is going on the right way. I'm learning a lot and I'm looking forward to every Saturday season. But I guess it's not the same for everyone because the people who came last time are not coming this time, and we need to think in a way that it attracts more people so that it gets more interesting. But how to do that is a question. Um, so for me, everything seems to be perfect. I think if everything goes good, I am ready to volunteer the next session as well. Uh, but I'm not sure how to gather more people.
Okay, yeah,
Yeah.
yeah. We'll figure that thing out, and I can also add a feedback form of some kind on the group, like generally what other people are or think about that. But yeah, I mean, the goal is just to be a bit better with every meeting, so that over time we get really good at the learning. So in 1 hour we learn a lot. Like that would be the goal. So let's keep it step by step and try to see how we can improve in that. And also for the process, like what are your feedbacks on the process?
The process is perfect, I guess. One thing that could be like we can stick ourselves to a certain time limit. For example, if we start at 12:30, maybe we can try to finish everything within 1:30. Like putting it
Okay.
a hard constraint could be one good point because not like everyone will not be in a point to extend, or if we have a hard constraint, sometimes we try to optimize the time of our presentations and we try
Yeah.
to be very specific. So that is something that brings quality.
Okay.
Apart from that, I guess most of the everything is perfect. Apart from that, yeah.
Okay. Yeah, regarding the
And
time
I think
thing. Sorry.
I feel one thing like because of this time constraint, it's okay to be here in Europe like 8 p.m. Saturdays, but it
Yeah.
need not to be that everyone from different parts of world are comfortable with this timing.
Yeah. Yeah.
So I
Yeah.
would say like there should be two timings for the same presentation, so that if at all people would want to join both the presentations, both the meetups, it's fine. One should be in the morning and one should be in the evening, so that the different parts of the people, parts of the world can join meetups.
Okay.
Right now, like people from India are having the trouble like it is
Yeah. Yeah.
from
Yeah.
the people.
Yeah, that's true. Actually, in India, it gets pretty late, so I was thinking of making it a bit early. But yeah, that's also a good idea that we can have like multiple meetups depending on
Yes.
the time zone. So different
Two
kinds
meetups.
of people would be joining. Yeah.
I would suggest two meetups every Saturday. One can be in the morning, one can be in the evening. So people from different parts of world can adjust to the timing quite easily, and they can join.
Okay. Okay. Yeah, maybe then I can also assign like because yeah, for me also it would be difficult to join 2 times on
Yeah.
Saturday,
So
but we can assign like some people who can.
yeah.
But let's keep it step by step. Yeah, let's try to do the 2 time thing as well. Okay. Yeah,
Sure.
Tanuj, how did you like it?
I think the presentation was quite good. Uh, what I wanted to add is that if if the presenter, like this time it is you, next time maybe it is someone else, if he or she has really worked on these projects, and if you can share the link of your GitHub profile where
Okay.
all these projects are. So suppose in this case, like suppose if I want to like apply this thing, of course I don't have any robot with me, but like if there is a simulation project,
Yeah.
the same thing, if you have done the simulation, then like
Hmm.
it's better that if I can do it, then that learning by doing is always better thing, right?
Yeah. I mean, that's true. I was previously going to make a repository of demonstrating this thing, but yeah, I couldn't get the time for that. So yeah, okay, that's I'm writing these things down. So I think ideal would be to share a GitHub repository or something, some mini project or something.
So, adding to what Tarun just said, in last week, I guess, or last week. So there's one person called Tehnan in this server.
Yeah.
So me and Tehnan basically started this ROS workshop, kind of small ROS workshops where we were kind of meeting Monday, Wednesday, and Friday in the same server, and we decided to work on something similar. So Tehnan has created a small repository where there is a 2D, like a small simulation vehicle. So we're implementing G mapping, adding move based flex, and doing random stuff to it to just keep on touch with ROS and keep on touch with C++ ROS, just to free our hands. So if you're interested, maybe you can also join us. Like we do it, we are still in this process, and we have this repo thing going. Yeah.
So are you doing it currently as well, Apurva, or is it on a pause right now?
No, we are doing it, but it's basically like last Friday I was not able to catch up with Tenan, so I need to just sync with him. But we have the repo and we do it basically. But we are
Okay.
only two people, so yeah.
Mm-hmm. Yeah, I think, yeah, if Tanuj, that is interesting to you, maybe you can join, and maybe you can share it in the member event section, right? Because I don't think a lot of people are aware of this thing.
Exactly. I was just thinking to ask Tanan once, what are we still continuing? Like we have completed a bit of it, like we implemented this G mapping part. So how to take it further? Like we decided to do random things, like anything that is going. So I will just let him know, and then I will tell you. So you can put a server announcement. Maybe anyone else
Okay,
wants to.
okay.
Yeah.
Yeah, sure. Yeah, sure. Just let me know, and maybe I can announce also in the main channel. But I would encourage that you also announce in member events,
Sure.
because that is, yeah, accessible to everyone. Hmm. Okay.
Okay.
And yeah, I think Akshay is left, right?
No, for what I mean, it's it's all good. The only thing I'll say, yes, I agree. Everybody do say that we can adjust the time, and that's something I'll say. Since it's said by everyone, it's pretty much there. But I do have one request. Please not to, if you want, you can have altogether another session, but not to cut down that brainstorming. Because what I feel is
Okay.
that before you answer the question, it will let everybody think that what can be a possible solution, that actually pushes your boundary, that okay, what can be a possible solution. Because once you give the answer, then you lose that curiosity, that okay, yeah, we can do it. Then you
Yeah.
kind of get biased that yes, that is one way, and then you tend to find solution only in that way. So I'll request not to remove that brainstorming part, and if you want, you can have it all together another session before a presentation or something like that.
Yeah. Yeah, I think Vamsi wasn't saying to cut it. I think he was just saying that we should reduce it a bit because it got extended to
Yes, exactly,
long time.
exactly.
Yeah.
No, I'm not saying that he's saying cutting. No, I understand, because it can be a lengthy process and sometimes it can be very short. So
Yeah, yeah.
it's completely, every time it depends upon the topic. So we
Yeah, for
cannot
sure.
actually say that this is how it has to be. But yes, it's just my request because I really enjoyed that brainstorming part. So that is my input.
Okay, yeah, thanks. Glad to know that you found it helpful. Yeah, okay, I'll consider that as well. And let's see what we have in the agenda right now. Yeah, so after the feedbacks, I think, does any one of you have to share his or her project progress or anything? I don't think so. Okay. If no, then I think we are now open to uh, casual networking. So if some of you guys want to just interact casually, you can join one-on-one chat rooms or any other audio channels if you want to communicate individually, or write on the chat rooms, give your feedback, uh, or just have like casual networking if you want to. So yeah, that's it from my side. So thanks a lot, guys, for joining today's session. I particularly enjoyed today's session, and we had like really good discussion. And I'm glad that you found it helpful as well. So, for the next part, for the next week, let me know if any one of you wants to volunteer, and you can write it in the volunteer meetup channel, and I'll fix your slot there. So that's it. If anyone wants to say anything else, and you can say, and otherwise we're done for today now. Okay. Okay. Thanks a lot for joining, guys, and see you next week then.
Thank you. Thanks a lot. See you next week, guys.
See you. Bye.
See you all.
Bye.